just in case I say something useful, let's record this. So using formulae then, first steps, draw out the problem. Second step, identify the formula. Formula. There's quite a few squiggles there. Formula. Okay? Identify the formula you're going to use. And that's not always obvious because there's more than one formula to find forces, more than one formula for pressures and so on. So which you will eventually get a list of formulae for engineering. There's pages of these things. And if you tend to work in one particular area of engineering, then there's a few key formulae you tend to use. So there are a few that you use, but identify the formula that you need. To do that, it must obviously include what you want and what you know. An obvious statement. So like we were looking this morning, we had a formula to find the stress. So it's got to include the stress, the formula, and force over area. So we know the force and we know the area. And sometimes, as we found this morning, we know the force, but we don't know the area. So we then need to find another formula that will then allow us to find the area, knowing the diameter, for example. Okay? So identify the formula. You must include what you want and what you know. And then something that wasn't an issue particularly this morning, because it was a fairly straightforward formula, is the formula in the right form? If I want to find the stress must be the subject of the formula. If I want to find the force, I have to rearrange it to make the force the subject of the formula, and so on. So you get the formula in the right form. Next, check units are consistent. And I fell into that trap this morning, didn't I? We had millimetres for the diameter, but newtons per square metre for the stress, so I needed to do some conversions to make the units consistent. Check the units are consistent. And that, of course, includes two. Convert prefixes back to engineering notation, which we had to do. So check units are consistent. At this point, we can enter figures and do calculation, or do calculation. Actually, if you could just drag this down a bit and leave a gap so you can put something else in. There's something else we could do first, and that I was trying to get you to do. Estimate, yeah. If it's possible, estimate, have an idea what to expect, so that when you do the calculation, you can see whether or not. Yeah. So, do the calculation. If you have done an estimation, then you've got a way of saying, yeah, that looks reasonable. So you do the calculation, and then you give your answer with units and to an appropriate accuracy. And to preempt the question about exams, if you give me an answer that's right in the exam, I'll be so happy that I'll give you the mark. Okay? But if you're out on an engineering site and you give an answer with about 100 decimal places, then that doesn't show good practice and good understanding of the subject, really. You should be giving it to an appropriate accuracy and stating what that is, okay? So the accuracy comes from the measurements you enter, you put into the calculator. Not the calculator, okay? Not the ability of the calculator to give decimal places, for want of a better word, okay? So just because your calculator is giving you lots of significant figures, it doesn't mean to say it's an accurate answer. The accuracy comes from the measurements you put in.